And welcome back, and we're going to continue our discussion of molar mass and moles and chemistry and how it applies to AP Bio. So in our last session we talked about the molar mass, which we're going to have to remember. And what we're going to look at now is we're going to look at how moles and mass are related to each other and actually do a little dimensional analysis. You can groan now, but we're going to look at how we convert from grams to moles and backwards as well. So anytime we convert from a mass to moles, we need to know the molar mass. So quick review, I'm going to do two that we looked at last time. So I'm going to use sulfuric acid and glucose. So we calculated the molar mass of these, and I'll go through real quickly again. So again, hydrogen, sulfur, oxygen, 2 hydrogen, 1 sulfur, 4 oxygen. So times 1 times 32 times 16, and we get 2 grams, 32 grams, and 64 grams. So the molar mass of sulfuric acid is 98. So we need to remember that number because this is what we're going to use in a couple of our examples. Glucose, carbon, hydrogen, and oxygen, 6, 12, 6. So it's times 12 times 1 times 16, 72, 12, and 96 for a total of 180 grams. So just real quick, we'll remember those two numbers, 98 and 180, and we're going to use those in our examples. So the first one we're going to look at is what if they ask us how many moles are in a certain number of grams. So the first one we're going to be given moles, we're going to be given grams, and we're going to convert it to moles. So here's the first one. Make a better Y for you there. How many moles are in 75 grams of glucose? So again, you may remember this from chemistry last year, setting up dimensional analysis problems. I like to say, what's the question first? So the question is, how many moles? How many moles are equal to 75 grams of glucose? Now it's all about the dimensions, the units. And for glucose, we found out that there was 180 grams that are equal to 1 mole. And we know in this case that the 180 goes on the denominator so that the grams can cancel out. And now we just 75 divided by 180, we can have two significant figures. So our answer comes out to be 0.42 moles. Okay, second example. How many moles are in 250 grams of sulfuric acid? And again, for AP Bio purposes, the dimensional analysis is going to be pretty easy and straightforward, but the question is, how many moles are equal to 250 grams of H2SO4? If you can get the setup, you really can't go wrong because you know now that grams has to go on the denominator. In this case, it's 98 grams. That's what we calculate the molar mass of sulfuric acid is equal to 1 mole. The grams will cancel out. We're left with moles as our unit, and in this case, with two significant figures again, it comes out to be 2.6 moles. So again, our answers in this case, 0.42 and 2.6. Now, what happens if we go the opposite direction? What happens if they give us moles and we want to go to grams? So now we're going to go moles to grams, and the setup is almost identical. how many grams are in 3.2 moles of glucose. So again, what's the question? How many grams are equal to 3.2 moles of C6H12O6? And again, we almost can't go wrong. What unit has to go in the denominator? Well, it has to be moles in this case. So we know that 1 mole is equal to 180 grams. Moles will cancel out. We're going to get our answer in grams. Again, we can have two significant figures. So in this case, it comes out to be 580 grams. Last example, we'll do one with sulfuric acid. How many grams are in 0.25 mole of H2SO4? So again, frame the question. How many grams are equal to 0.25 moles? Again, we're going to use a conversion factor. In this case, again, moles has to go on the denominator. And in the case of sulfuric acid, we know that 1 mole equals 98 grams. Moles will cancel out. 0.25 times 98. And we get an answer of, with 2 sig figs, of 25 grams. So there we go. So there's real quickly how to do the dimensional analysis and how to use molar mass to allow us to convert between moles and grams or vice versa.